Good morning, boys. We are again here, have a fresh start, and we are trying to give you some information, important information that due to the changed condition, COVID-19, everything is uncertain, as you know, boys. So here we are giving you, I am giving you, all teachers will give you some important home assignment. That home assignment is necessary for every boy, and you have to do the home assignment in a separate copy, subject wise, giving date, and you have to produce that hard copy to us for checking. And internal assessment will be there. Marks will be given on the basis of your home assignment. Okay, so boys, the chapters which we have completed, already I have completed chemical kinetics. I am giving you home assignment from chemical kinetics. You have to answer, you have to write the questions there clearly, giving date. This is the assignment of January, you know. You have to write the name of the month that you have done it in the month of January, and you have to solve all the problems writing the questions. So from the video, you must note down the questions which I am giving before you in the class. So this is the first question, that nitrogen reacts with hydrogen to form ammonia. At the very first part of the chapter, you will see that how to find the rate of the reaction on the basis of rate of formation of the product and rate of consumption of the reactant. You know that stoichiometries, the stoichiometric coefficient have a special role there. So this is the very initial form of finding the rate, that the rate of formation of ammonia is given, numerical value is given, it is molarity per second, rate of formation of ammonia is given, you have to calculate the rate of the reaction. Rate of the reaction means rate of the overall reaction. You know that rate of this overall reaction depends upon the rate of formation of ammonia, the rate of consumption of hydrogen, and rate of consumption of nitrogen. So the individual rates of consumption or formation, those rates may vary, but the overall rate depends on each and every substance involved in the reaction. So listen to me, you have to calculate the rate of the reaction, number 1, and number 2, the rate of disappearance of hydrogen. So this is the rate of formation of ammonia given. You have to find the overall rate of the reaction, and you have to find the rate of disappearance of hydrogen. This is question number 1. You will solve it beautifully, and you have to present it before us when you will come to the school premises. So on the basis of this, your assessment will be done. Remember it, home assignment, assessment will be done. Question number 2, this is another question based on order. You know what is order and what is the meaning of order of the reaction. This is a reaction 2A plus B, two products. The rate of the reaction is doubled. The rate of the reaction is doubled for doubling the concentration of A. When we double the concentration of A, the rate of the reaction is doubled, keeping the concentration of B unchanged. And when we are doing it, concentration of B is not changed. Another point is rate of the reaction becomes 4 times, and the same rate of the reaction becomes 4 times for doubling the concentration of B. When the concentration of B is doubled, rate becomes 4 times, keeping the concentration of A unchanged. Second part, we are not changing the concentration of A. So you have to find the order of the reaction with respect to A, and order of the reaction with respect to B, and the overall order of the reaction. That you have to express the rate expression, you have to write the rate law for this reaction, and also find the unit of rate constant. You know that unit of rate constant varies from order to order. If the order is changed, the unit of the rate constant will also change. All things you know. Now, these are two questions that you note down. Third question is related to the kinetics of the reaction. You know that for zero order reaction, rate is written, rate equals to K into concentration of the reactant power 0. That means that for zero order reaction, this is for zero order reaction, rate of the reaction does not depend on the concentration of the reactant. Clear it. Rate of the reaction does not depend on the concentration of the reactant. It is power 0. So, rate equals to constant. Rate is constant, means rate does not change even if we change the concentration of the reactant. Secondly, this form in the differential form, if you write, this is the differential form of zero order reaction, minus dr by dt equals to K. This is the differential form, note it, differential form of zero order reaction. Similarly, rate for the first order of reaction is K into concentration of R power 1. We may write 1, we may not write 1. What is the power? Power is 1. So, what is the order? Order is 1. First order reaction. So, this is for first order reaction. Now, the differential form, if you want to write the differential form of first order reaction, the form will come like this, minus d r by dt. This is equal to K into concentration of the reactant. This is the differential form. So, I want to mean here that how to write the differential form of zero order reaction, this one, how to write the differential form of the first order reaction, this is 2. Now, you know the integrated, these forms are expressed or converted to integrated form. The integrated form of first order reaction is very important. The integrated form of the first order reaction, from there you have to solve many numerical problems as we find in the book, as we find in the examination. So, what is the integrated form? Integrated form of first order reaction is integrated form of first order and second order, and zero order reaction. You will write it, reaction. This is your question number 3. Integrated form of first order and zero order reaction. You will do it in your home assignment copy. Integrated form of zero order reaction, integrated form of first order reaction. You will derive it, derive them. Okay, from differential equation to integrated equation, derive it. From differential equation to integrated equation for first order reaction, you will derive it. Now, I am writing the integrated form of the first order reaction is T equals to 2.303 by K log R naught by R. This is the, directly I am writing it, this is the integrated form of the first order equation, 2.303 by K log R naught by R, this is equal to T. Time equals to 2.303 log R naught, 2.303 by K log R naught by R. This log is base 10. This is the integrated form of first order reaction. From you have to solve many types of questions, numerical questions, okay, and its T half, that is half life period, this is equal to 0.693 by K. So, see boys, number 4, after deriving After deriving this equation, after deriving the T half for first order equation, T half is independent to the concentration, initial concentration of the reactant, you will solve this question related to this equation. First order reaction takes 40 minutes, 60% decomposition. First order reaction takes 40 minutes for 60% decomposition. So this is given. A first order reaction takes 40 minutes, this is the time given, and how much reaction has occurred? 60% of the reaction has occurred. You have to find the rate constant, find the value of K and T half for the reaction. T half for the reaction. So this is your question number 4. First order reaction takes 40 minutes for 60% decomposition. Find the value of K and T half for the reaction. You will calculate T half. You will calculate the find the value of K. You know that this is R naught. Keep R naught as initial concentration, and what is R? R means the concentration of the reactant after time t. So concentration of the reactant after time t, that you will calculate. 60% of the reaction has completed. So 40% of the reactant will be left after 40 minutes time. So you know how to calculate it. You will do it. Now the question is that you know that first order reaction, the T half for the first order reaction is independent to the initial concentration. That means whatever be the initial concentration of the reactant, it will take same time for 50% decomposition. 50% decomposition, it will take same time for 50% decomposition if the reaction is of first order. Now you know that I am giving in question number 5 that how to derive the expression of zero order reaction integrated form, and there you will find the half life expression. There you will derive the integrated form of first or zero order reaction, and you will find the half life expression. Now I am giving question number 5, the half life period of a first order reaction is 60 minutes. Find in what time half-life period of first order reaction is 60 minutes. Find in what time the reaction will undergo %90 decomposition. Here one thing I mentioned, just see, you have to use the log table, you have to consult the value of log 6, log 4, whatever be it, during solving the problem, you will use the constant value of the log, okay, from your table, from your log book. You will use the constant values without any what I say, confusion. So this is question number 5. Now question number 6, you will write question number 6, find a list the points of differences between rate and rate constant. Rate and rate constant. You will list the points of differences. This is your last question. Last question means up to 6 questions I have given you, and all the 6 questions answers you will write in a chemistry copy, and that will be titled, my name will be titled there, my name giving the title that who has just given you the assignment and to whom you have to submit. You have to submit your assignment to me, okay. So you maintain your homework copy. This is very important for you. Once again I am telling. So it is very important for you. After going through the chapter, you will solve these questions. This is part 1. In the next class, I will give you some more questions that you will list the questions and you will write their answers clearly. And you have to submit before me your copy to be submitted. Okay boys, thank you.